Hi folks, today we're going to talk about domain and range of functions. So domain and range of functions. The essential question that we're going to answer today is what is domain and range, which you should probably be at least a little familiar with it from Algebra 1. But we're going to dive deeper. What is domain and range? How do we find it from a graph? And how do we write it using the three notations that we discussed yesterday? So how do we write it using the three notations? Take a minute to try and remember what the notations were yesterday. There were three of them. We had inequality notation. The real easy one was interval notation. And then we had set notation, which was pretty easy because if you wrote inequality notation, that went into set notation. So we're going to figure out what domain and range is today, how do we find it from a graph, and how do we write it using the three different notations from yesterday. Well, the first essential question is answered here. The domain is the set of all what? X values for which the function is defined. Defined means like the function has a value here. So the domain is the set of all x values for which the function is defined, for which the function has values. The range is similar. It is also the set of values, but it's the set of all y values, also for which the function is defined. So, yesterday, for our three notations, we learned that some symbols just kind of go together. So I'm going to, in this blank space, kind of try and help you remember about what goes together. So yesterday when we were talking about our notations, we were talking about points that were closed and we were talking about points that were open. And this helped us determine what symbols to use when we were writing our three notations. So if we were writing inequality notation and we had a closed point, we would use the less than or equal to sign. Remember, more shading and more in the inequality sign with the line underneath, the or equal to line. If you had an open point, then you would use the less than symbol. So it's missing the shading inside, it's missing the or equal to line in the inequality symbol. So those are some easy ways to remember. When we talk about interval notation, if we had a closed point, we would use a bracket. And when we had an open point, we would use a parenthesis. Now, in addition to open points, we also used parentheses when we just had the solution set extend to infinity. So I'm going to lump that in there too. So that's just kind of a review of the things that go together. Now from yesterday, we have our inequality, interval, and set builder notation, sometimes called set notation, sometimes called set builder notation. So I've got kind of the layout of the way that they were yesterday. Now the difference today is that instead of having a straight like a number line, and instead of having like a point that's shaded or open and then shading to one side, instead of having that type of graph, today we're going to have like two-dimensional graphs. So we're going to have x values, we're going to have y values, we're going to have the graphs go side to side and up and down. So one of the things that's really useful is a highlighter. If you're using Kami, then you can use the highlighter function. If you're not using Kami and you actually printed these notes out and you're writing on them and you're going to scan a copy to me later, then you can actually use a highlighter. So if you don't have one and you need one, go pause the video and go grab one. So in our notations, if we start out with the domain, remember that the domain is the set of all x values. And the x values are along the x-axis, which moves from the left to the right. It's the horizontal axis. So for inequality notation, we're going to have the left bound on the left side, the right bound on the right side. For interval notation, we have the left bound on the left side, the right bound on the right side, and then same thing for set builder notation, but remember we have this X and this bar. Now I do want to mention, and we will not do this typically in our class, but sometimes you will see this. And this is not something that I expect you to write in your answer unless you just want to, but it is something that I expect you to recognize. So the way that you pronounce this is the set of all x values. Remember before it was the set of all x values such that, and then you gave your inequality notation. Here it's the set of all x values that are in the real numbers. Remember, this thing is like all real numbers. Okay, it's just what it looks like whenever it's typed instead of written. So the set of all x values in the real numbers such that, and then you have your boundaries that are happening in your inequality notation. So not, but I do want you to be able to recognize it if you do see it on a test or if you see it on like the PSAT or something like that. So I'm going to go ahead and move my paper up. I want to do some examples with you. Okay. There we go. So I have my highlighter. Remember that my domain is the x values, the set of all values from the left to the right. So what I'm going to do with my highlighter here is I'm actually going to draw the boundary on the left and the boundary on the right, as if I were boxing in this function and making it all fit in a nice little rectangle. I'm going to draw the left boundary and the right boundary. So I go find the part of my function that is the farthest to the left. That'd be this point right here. So the boundary, if I were putting this in a box, would be like that. Do you see that? How I just kind of drew a boundary right there? Same thing on the right side. Remember, domain is left to right, so I need the left boundary and I need the right boundary. So I'm going to go all the way to the right side with my highlighter. That right boundary is right here. So if I were to box this function in, its right boundary would be just like that. Do you see that? So if I wanted to, I could put a little line segment up here and down here, and I could actually box it in, but for the domain, all I care about is the left side and the right side. So I have my boundaries, and I have a habit, and I think that it's a pretty good habit. Most students find that it's useful. I have a habit of going and finding exactly where my boundaries cross and what type of point is on my boundary. That way it helps me to create these notations. So this boundary is going through this x value right here. So that's negative 1, 2, 3, 4, 5. That boundary is at an x value of negative 5, and the point on the left side of my function that's on that boundary is a closed point. Do you see that? So those are the two things that I'm going to put over to the side. On the right side, this boundary is going through this x value. That's an x value of 1, 2, 3, 4. Okay? And the point that's on that boundary is open. Do you see that? So that's what I'm going to note right there. Now, when I write my inequality notation, remember that I'm using domain, so I'm using x values. My inequality notation, I've got the x in the middle. My left boundary is negative 5. My right boundary is 4. My point with negative 5 was closed. So what symbol did you write at the beginning of your notes that goes with a closed point? You wrote less than or equal to. And what goes with an open point? You wrote the less than sign. So there's my inequality notation for my domain. It's very similar to what we did yesterday. It's just that this time, because we had a two-dimensional graph, I actually had to find my boundary lines on the left and the right side. So I'm going to go on to write my interval notation. My boundaries were negative 5 and 4. I have a closed point, which indicates a bracket, and an open point, which indicates a parenthesis. So there's my interval notation. And then finally, set builder notation. I'm going to open with a brace. So it's the set of all x values such that, and then remember that this comes down and is inserted into set builder notation. There we go. So I want you to pause the video and I want you to try example 2 using either your highlighter or the highlighter function in Kami, remembering that when an arrow is in your graph, that means that there is no boundary. So take a moment to try example 2. Pause your video. Okay, folks, hopefully you've had the opportunity to try number 2. If not, pause the video again and try to finish. I'm going to go ahead and work number 2, but I'm going to work it a little bit faster the way I would typically work something, and I'm just going to kind of annotate what's in my head as I'm going through. So on example 2, domain is x values from left to right. I see an arrow, so there's no left boundary. That means that it's going on forever in that direction. My right boundary is over here. I notice that since this goes forever in that direction, it's going to negative infinity. And this is going through an x value of 1, 2, 3, 4 with a closed point. So I would say that I have no bottom boundary, or sorry, my left boundary, I don't have one, but I've got a boundary on the right side. Closed point means I use less than or equal to. For interval notation, the left side is negative infinity. The right side is 4. Infinity, I always use a parenthesis. Closed point, I use a bracket. Set builder notation, the set of all x values such that, and then I bring this down, x is less than or equal to 4. How'd you do? I hope you did all right. We're going to go ahead and move on to range. Range is very similar to domain, except for that instead of the x values, you're using the y values. And instead of going from left to right, you're going from the bottom to the top. So let me go ahead and change to my range paper. Okay, for range, notice how everything here is exactly the same except for all of these things that used to be x's are now y's. And all of the places that said like left bound and right bound, actually I forgot to change this one. I'm so sorry. Make sure that you change this. This left bound should be the bottom bound. And the right bound should be the top bound. I guess I forgot to change that one. So remember that you always list your values from least to greatest. So if I'm talking about the x values, least to greatest is going to be left to right. But if I'm talking about y values on a graph, my least values are going to be down on the bottom, and my biggest values are going to be at the top. They're going to be higher. So that's why we've changed from left to right to bottom to top. So I write them the same way, except for this time I'm talking about my values from the bottom and the top. So in order to write my range, I need to find my boundaries. I'm going to find my bottom boundary first on example 1. So my bottom boundary, I go down to the bottom part of my graph. This and this are the same distance down. So here's my bottom boundary right here. And then my top boundary is that very, very top point right here. Now, something that I want to discuss with you is that even though you have endpoints that are open or closed, you also have all of the points in between that are defined on your function, on your graph. So here, like I have an open point here, or sorry, a closed point here, but I also have the rest of this like function and this line, and all points here, they're all closed points because they're all defined on the function. So I'm mentioning this because if I go all the way to the top, well look, there's no open or closed point right here. So how in the world do you know what it is? How do you know whether to use the less than or equal to or the less than sign or a parenthesis or a bracket. Well, anytime you see part of your line that has no open or closed point, you consider it closed. And the reason you consider it closed is because there's a part of the graph up here. So there's a closed point. There's a point where the function is defined up there. So that's just something to look out for, that anytime you have on a boundary a place that doesn't have an open or a closed point, but the graph comes and touches that boundary, you consider that a closed point. So I just want to bring that to your attention while we're doing these. So my bottom boundary, my y value goes through right here. So that's a negative 1, 2. Negative 2. Do I have a point that's defined on a y value of negative 2? Well, I don't over here because that's open, so that point's not defined. It doesn't have a filled in space. It doesn't have a value. It's kind of like a placeholder. But over here on negative 2, I've got lots of points where y is defined. So I'm going to say that this bottom boundary is closed. If you have both open and closed on a boundary, you consider that boundary to be closed. Up here, here's my y value, 1, 2, 3, 4. And we talked about how if there's no open or closed point, you consider it closed. So for my range, my y values, well, my y values are between negative 2 and 4. So from my least to my greatest value, both of these are closed boundaries, so I'm going to use less than or equal to in both cases. My interval is from my bottom boundary to my top boundary. Both boundaries are closed, so I use brackets. And for set builder notation, it's the set of all what? It's the range, so it's the set of all y values such that negative 2 is less than or equal to y, which is less than or equal to 4. So remember, range is your y values. You're going from bottom to top. So I want you to take a moment to pause your video and try example 2. So I went ahead and drew my boundaries in for the range. Remember, the range values are from the bottom to the top, so I need a bottom boundary. Notice how it's not here. It's not here going through that closed point right there. It's the very bottom of the graph. So like the lowest place that the graph will go, that's where you draw your bottom boundary to. So it's not going to have a boundary going through the function. That's not going to happen. And then the top boundary, well, I don't really have one because I have an arrow that keeps going to the left and up. So there's no boundary there. So in real time, this is what I would do. I'd find my y bottom boundary, which is negative 1, 2, 3, 4. I remember that, I remember that Miss Belsick told me that anytime I see a part of the graph that doesn't have an open or closed point, I need to consider it closed. So that's negative 4 with a closed boundary. And then on the top, since I don't have a boundary and it's going up, that's going to positive infinity. So my inequality for my range, my y values, I have that bottom boundary of negative 4. It's a closed point, so I use less than or equal to. I don't have a top boundary, so I don't put anything. My interval notation, my graph goes from the bottom of negative 4 to the top of infinity. Infinity always has a parenthesis. My closed point has a bracket. And then finally, set builder notation, the set of all y values such that, and then I bring this information down here. Negative 4 is less than or equal to y. So take a moment to review your domain and your range examples and write a 1 or 2 sentence summary just about a few things that you should remember about domain and range.